Hello and welcome back. And today we're going to talk about the introduction of graphing sine and cosine functions. Now, since we graph trigonometric functions in the xy plane, we will use x for the independent variable and y for the dependent variable. In other words, y is a function of x. Now, we've written 6 of the trigonometric functions in terms of x, and I want to read them off to you. Say y is equal to f of x is equal to what? Sine of x. And we have f of x is equal to the cosine of x. Of course, f of x is equal to tangent x. F of x is also equal to cosecant x. And f of x is equal to secant x, and f of x is equal to cotangent. So, basically, what we're doing here, we have to understand the behavior in the graph of the sine function, which is y is equal to sine x. And we're going to talk about a few things about that. Sine function has a period of 2 pi, and only graph y is equal to sine x on the interval of what? 0 to pi. And the remainder of the graph will have this repetition of this portion of the graph. Meaning, basically, when the graph it has a period from the origin to 2 pi, from 0 to 2 pi, it's going to continue to have this looping behavior, or this amplitude, like a heartbeat, right? On the monitor, right? On going to positive infinity and also coming from negative infinity. So basically, we're just going to look at where the origin of the graph from 0 to 2 pi, right? We're just going to look at that, basically, so we can see how the graph is actually functioning, right? So basically, we create a table which lists the points on the graph of y is equal to sine x, and you have this interval. And from 0 less than or equal to x less than or equal to 2 pi at the beginning of the origin. Now, as x increases from 0 to pi over 2, the value of y is equal to sine x it increases from what? 0 to 1, as x increases from pi over 2 to pi to also what? To 3 pi over 2. And the values from 1 to 0 and 0 to negative 1 as x increases from what? 3 pi over 2 to 2 pi. And the values of y increases from negative 1 to 0. So, as you look at this table here, we developed the table, created a table, and then from the table we put points on the graph, and then draw a nice smooth curve here, as you see. So this is figure 1. And it has, and again, we mentioned that it has a period of 2 pi. You see this. From the origin here, smooth and continuous, to 2 pi. And what I was trying to explain earlier, as it continues on, it continues the same behavioral pattern, like a heartbeat, right? All the way down, like a wave. From this, going this way to positive infinity, and also coming from what? Negative infinity. So as we see right here, it shows a continuation of what it's doing, right? So basically, that's what we were trying to show and trying to explain to all you students out there that are learning trigonometry. And I want to present to you a formula, A times the sine of omega times x. And that basically is showing you that A is the amplitude of this function. So when you have y is equal to sine x, right? Just make mention of that. That's understood there to be a 1, right? That's understood there to be a 1. So therefore, your amplitude here of positive 1 and your amplitude here of negative 1 here. So we have this from the period 2 pi you have the amplitude coming from negative 1 to positive 1. So this is what we have here. And this is our amplitude. From negative 1 to positive 1 is our amplitude here. Now, let's talk about omega for a second. So here in the formula, that's understood to be 1x. And the coefficient 1 is where you will substitute that in for omega. And as you see right here, this is the formula period for the period. It's equal to 2 pi divided by omega. And so omega will be substituted, will be used, well, 1 will be substituted in for omega. And so it'll be 2 times pi divided by 1, which is equal to 2 pi. So this is where the period is being established, if you will. Come follow me and let's talk about some properties real quick. Talk about some properties of the sine function. Now, as you can see, the domain is a set of all real numbers. And the range consists of real numbers from negative 1 to positive 1 inclusive. Now, that's considering what? That you have an amplitude of 1 right here, remember? So that's understood to be a 1 there, which is the amplitude. So that's what your range is. If you was to put another value of some value a, which is some real number, then that will also be your range in that fashion, from negative a to positive a. Now, sine function, what do you think the sine function is? Is it an odd function or is it an even function? What do you think? Can you tell me? What do you think? If it's with respect to the origin, remember from the old algebra days, when you had an even and odd function? Well, it's kind of the same thing here in trigonometry. The sine function is an odd function because the graph is symmetrical with respect to the origin. Okay? And the sine function is periodic with period 2 pi, and the x-intercepts, right, are established here where you have some values coming from negative infinity to negative 2 pi, negative pi, 0, pi, 2 pi, so forth and so on. We have y-intercept is 0, and our maximum value is 1, and it occurs at x from some values coming from negative infinity to what? Negative 3 pi over 2, pi over 2, 5 pi over 2, 9 pi over 2, so forth and so on. And the minimum value is negative 1, the minimum value is negative 1, and it occurs at x equals from some values coming from negative infinity to negative pi over 2, 3 pi over 2, 7 pi over 2, and 11 pi over 2, so forth and so on. Now, let's look at a few examples of transformation here. So we see the regular sine function here. And we're going to see a vertical transformation here. As we multiply 3 to the function, you'll have a vertical stretch, a vertical transformation. Here we go with the amplitude now being what? 3, right? 3 from negative 3 to what? Positive 3 in this case, because here's the value of a, remember? We talked about that formula briefly. So that 3 is the amplitude, right, of this function. So, again, multiplying by 3 causes a vertical stretch, right? Because it's the factor 3 is being multiplied there. Now, again, let's talk about the period, right? What is the period in this case? Because there's a vertical transformation, there's something happening with the period, is it not? So, look at this here. we have this understood still to be 2 pi. In this particular case, because y is equal to 3 times sine x, right? It does not change the period. It does not change the period in this particular case because this is understood to be 1. Our formula for the period is equal to 2 pi over omega. 1 will be substituted in for omega. So 2 pi over 1 will still be 2 pi. So it doesn't really do anything with the period. Like I said before, it's a vertical transformation, it's a vertical stretch, right? So the period will still be the same in this particular case. However, things are a little bit different with this one here. As we talk about graphing y is equal to negative sine, right, 2x. Well, for one thing, the amplitude here, you got 1 as the amplitude, but it's a negative 1 here that's happened to be multiplied to the function, so that causes this thing to reflect about the x-axis. You see this, right? So the amplitude still is coming from negative 1 to positive 1 in this particular case, because this is, you have, when you actually have the function coming from negative infinity to positive infinity, here is where your range is. Your range is going to be negative 1 to what? Positive 1 in this particular case. Because of this. When we multiply by negative 1, it reflects about the x-axis. Let's talk about now, when this transforms, the period here is still what? The period is still 2 pi, but when we get to this one, where 2x is being substituted in for x here, now here's where we have a different period. Why? We have a different period because omega now is 2. That will be plugged in for the omega value. So the period here is still equal to 2 pi omega, and it equals to 2 times pi times 1 over omega. So it'll be 2 pi times 1 over what? That 2 right there. And so when you actually do the math and say 2 pi over 2, and of course 2 cancels out and it becomes just pi. So now, because you have a replacement of 2x going into the variable x here, there's a horizontal compression by the factor of 1/2. And that's because this here, 1/2, this is what we're talking about here. Because omega, that 2 goes into the, substituted into the variable for omega. This factor of 1/2 is this, what we're talking about here, multiply the 2 pi and making it compress. So that's why the period will change in this particular function. So we will talk about cosine functions on the next video, and we'll see you